Sorry for being late. I fell asleep because I get up late, terribly early this morning.
Hi, 可夫。
Hi, Shenmei.
We are waiting for you.
Oh, sorry keep you guys waiting. Rita, good morning.
Jet lag?
No, sure. Probably just too nervous regarding to the talk this afternoon. Anyway.
Hey, 建鹏, we can't hear you. Are you talking?
Yeah, 可夫, I have a question about your mail yesterday you sent.
Sure.
Can you hear me, 可夫?
Yes, I'm listening to you clear and loud.
Okay. In your mail, you mentioned for the first method you mentioned all shard can allocate OSD map.
Yes.
Why not make a shard 0 to allocate OSD map?
The idea is that I really want to avoid the memory copy, because if any of the core is able to allocate the memory for the OSD map, in a lot of cases we can just save the memory copy, because the payload in the because when decoding the payload in the MOSD map message, if if the core where we accept the message and the core where decode them is the same one, we can avoid the memory copy. Is that right?
If other shard dispatch the message, if the message is the OSD map, it can submit to the CPU door to do this. This also avoid the memory copy.
But
guys,
but
do we need? Oh, sorry. Please continue.
But any core can 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 accept the connection from its peer, and any core can 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 be the connect can be a core which connects the monitor. Is that right?
Every core can connect a monitor.
Yeah, because there are three sources of OSD map, right? One is the monitors the the message from the monitor, and the one from the message from its peer OSD, and one is the buffer list from the metadata collection.
Guys, do we need to really take care of updating new of handling new OSD map performance? I thought initially that this operation is quite infrequent. My testing, well, I can see that OSD map update. I've got a couple of revisions of OSD map just during initial setup of cluster. Then it's almost read only. Maybe performance is not a critical factor here.
Yes, I think we can just get some first implementations and then check if there is a performance effect there.
Personally, I would prefer to if a given thing is not on a hot path, I would really prefer to keep it as simple as possible.
Yes,
And
I feel the same.
even if it requires a huge amount of mem copy, but it's infrequent, but it is infrequent, then fine, I guess.
Yeah, but we still need to exclude them from Seastar threads, right? Because the existing implementation have logs that will block some.
Sure,
that will have
but even
block,
if we need,
right?
of course, but even if let's suppose that we block the wall reactor for some time, if this happens infrequently, it doesn't translate into some kind of deadlock, well, maybe still it's acceptable.
Why do you think it's blocks, in here?
I'm not quite. I didn't look into that, but if the original implementation is can be accessed across cores, and I assume that there will be some logs inside, right?
I'm not sure which part
So
we have which part of which path we block the core. As long as we pass the I mentioned just we have a three source to have a OSD map.
mhm.
None of them have a block. We require that we have a blocking core. We can always pass the read buffer list or the raw message to charge 0 and allow it to decipher or decode the core, decode the message or decode the buffer list and let it hold the OSD map as a central repository or registry of the OSD map.
Yeah, but yeah, if we just decode the message and decode the OSD map and submit to core 0, and there will be a much simplified. There can be much simplified implementation because there is only one thread as a working thread for the aerial cache, right?
What do you mean by working thread? I assume that there's a
Yes, there's. I just saw that email that the first solution is to implement a server client
yes.
side, so that there's only one server side thread, and it simplifies its implementation. It can simplify its implementation because originally the cache is not running on one thread, it's running on multiple threads. So there should be some synchronization. Okay. So if that is not necessary, so we can remove something inside that OSD map cache so that performance can be improved.
Probably yes. Yeah, I agree that it's simpler. I think that's also you are also echoing Sage's comments.
Yes.
So I guess we are on the same page. That the option one is the better solution, and we probably we have the luxury to we can withstand the overhead to do the memory copy because it's an unusual thing to get a new OSD map.
Yes.
Jianpeng, does this answer your question?
Okay.
So another update from my side. Yeah, I just did some POC implementation to enable sharded connections in Seastar Messenger.
Yeah, I noticed that the PR is still pending on review.
Yes, and the whole idea, why I think it is only a POC because it actually needs some interface changes in the first in the abstract level, like the connection and the messenger and the dispatcher. Yeah, because now that messenger is not, the data structure of messenger is not shared by all cores. It is a shared nothing data structures. And also the connection and the dispatchers. So there are some interface changes I want to show you.
So it's what do you mean? It's undetermined. So this is why you marked it with a POC or request for comment.
Yeah, because you have implemented monitor client, right?
Yes, true.
Yeah, it directly inherits connection object, and because now connection is sharded by its peer address, and it has to be changed if at the same time, but I'm not
Does
quite.
it change the what's the impaction of this change? Is it change the general program model of the dispatcher or It just change the interface of a dispatcher implementation.
The behaviors of the data structures
Mhm.
are different because of
Okay.
all the data structures are sharded by the peer address. So when we use connections, we assume that they are at the original, they are working on the original core of its peer address. So we should be aware of that in our implementations that depends on it. For example, if we implement some sending messages logics, we need to submit them first to the core where the connection lives. Just like the test I wrote there. Or if we don't do this, we need to submit to the core each time when a connection want to send a message or doing some works. So that's one change of this sharded messenger.
So connection is attached, I think, to a certain core. Is that what you mean?
Yes,
Okay.
this is I think it has impact on the current monitor client implementations.
I think the assumption is not changed with the before or and after your PR.
Yeah, I saw.
Because we also always assume that a connection is assigned to a certain core, even
Yes,
without your PR.
I saw that you create some new connections in monitor client, right?
Yes, that's a connection to monitor, I guess.
Yeah, but those connections should be also sharded by. It also should be sharded by PR address, right?
I'm not sure because it's a client connection, which is not a it's not listening. It's not listening or accept any connection from the peer.
Okay.
So I guess it's different.
Okay, I will check that, but because I didn't have chance to look into that, I just have some compare errors when implemented.
Yeah, but I guess it might be different in the case of let's say a server connection where we could have multiple connections from different cores, and yeah, if a client is attached to a server connection, it is supposed to be aware that where the connection is accepted. But in that case, I think the one who yeah, I think the interface of ms_accept should be bound to a certain core.
Yes, I moved when a connection, when a socket is accepted, the peer address is known by the messenger, right? Then the messenger just move the socket to the sharded core. And this is part of my implementation.
Cool.
Also, when we try to connect, there are some mandatory interface changes because when we issue connect, we don't know which core the connection lives.
But
right?
It's not supposed to know this. It does not change how succeeding behavior of that connection or the dispatcher attached to that connection. Am I right?
Yes, but yes, of course. But if the client using that connection wants to use that connection to send a series of messages, right?
Mm-hmm.
If that client is not at the same core, there are two ways.
Oh, right.
The first way is to when send a message, each time there will be a core switch there, right?
They need to post a message to the core, which establishes a connection to the peer.
Yeah, another way is to if we know there's a series of operations there, we can just submit the entire logic to that core and just send the message at the same core, right? That could be faster.
But we cannot predict which core will be sending a message. Will be using the connection attached to, for example, a connection established on core 0, and on core 1 we are trying to reuse that connection to its peer.
Mm-hmm.
We can hardly predict that which core will be using that connection for talking to the peer. So
Yeah.
we cannot move the connection to any of the core.
Yeah, let me have an example here. Let me see.
But what do you mean by moves that
Let me find
connection
an
to a
example.
Sure.
I'm just searching my code there. Sorry for a minute. Okay, so my code. Okay, I think I can share the screen. It seems it needs some extension. I can install it next time, I think. But this is an example of my code. So if a client that is guaranteed to use a connection is guaranteed to use one connection in its logic, right? This is an example here. It just use one connection to send ping pong, and we can submit the entire logic to the core where the connection lives, so that when the connection wants to send some messages, it doesn't need to do it asynchronously, to do it across cores, right? So it's just an example here. So even this client doesn't live at the same core of the connection.
Yes.
You can still submit some callbacks or continuations that is related to this connection, to this core.
Yes, that's what we get from Seastar, I think.
Yes, I think that's relatively new things with Seastar.
Right.
And another thing is that I changed all the the intrusive PTRs to Seastar smart PTRs, smart pointers, because if we want to manage the memories, we should change to use Seastar smart pointers, right?
You mean the connection?
Yeah, connection.
Oh, that's a little bit awkward, because the first thing that I don't really think we need to expose the shard where the shard ID where the connection is live. What I think ideally the interface the consumer of a connection does not need to know where the connection is attached to. I mean, it does not need to pass the shard ID on which the connection is attached to.
Okay.
Is that right? Because it's a for Seastar, we need to do it explicitly, but we can, when it comes to the interface of a dispatcher or connection, we don't need to make it explicit. We can hide it in the implementation of a connection.
Okay, I think it makes sense.
Yeah. The consumer connection just need to focus on the message and the continuation attached to the the send call. What happens we need to do after the message is committed is sent over to the wire.
Another consideration here is that there are two round to completion phases in the Seastar OSD, right? The first round to completion is from when the message is received by messenger and send until it is sent to a PG, right? The whole logic should be a round to completion in one call, right?
Ideally.
And another phase is when it is submitted to a PG, and inside that PG, the major IO path should be a round to completion
until we send the payload to Blue Store or
yeah,
whatever
to object store, right?
Yeah, the store living in the alien world.
Yeah, so how to guarantee that the round to completion is from messenger to PG? I think we may need to change the dispatcher to be a sharded service.
We do the PG sharded, right? So we couldn't run to complete in one call. We have to check the PG, which call the PG belong to, and send them a request to that PG sharded call.
So that's why there are two phases I mentioned. The first phase is from messenger to OSD, and the second phase is from PG to object store. Because it's because the connections have and the PGs have different sharding policies.
Yes. So for example, client send do the connection with call 0 and send the message. The message is for the PG on call 1. So the call 0 get this message and then do OSD do some things and check the PG group PG number. If the PG number belongs to PG1, they will send the message to the PG1. So the PG1 will
so
do the following PG.
Is how if we need to shard the OSD by the connections, because the OSD only knows the only knows how to submit messages until it knows where the PG it is, right? But before that, the entire logic can be run to completion. So that means
yes. So for example, in the code 0, it will run to all the OSD logic until it is needed to send to the PG layer because they need to check the PG ID, right?
yeah. So that it means some parts of OSD is sharded by connections.
Yes, connection is assigned by the kernel, right?
Yes.
It depends on the IP address and the protocol and the port number. They will assign the connection to balance on the cars, I think. So each car will get some connection, but this connection will process multiple PG's requests. But these multiple PC requests will cross all the cars maybe. So
yeah, only in OSD, right?
Yeah, OSD will be
yeah, dispatcher.
Yeah,
so
OSD will be a
let me
dispatcher and
listen
will
to me.
be a sharded service.
Yeah, so this process should be like this. Code 0 do the connection and get client message will handle the message until it get the PG number. Then we'll do the PG shard to send the other calls. The other calls handle the PG layer policy. Then they will send for example, if we use the blue style, they will send the traditional thread to do the blue style operation. After the traditional thread finish the blue style, they will return to that PG sharded call. And then that PG sharded call will return the request to the originally first call to return to the reply message to the client, right?
Yeah.
Yeah.
That is the parse, I think. It's long parse. Cross the course and the traditional thread.
I can recall that some time ago there was an idea to assign to basically avoid the switch of cores between related to PG sharding. There was an idea to us to bind, basically to move that logic to client, to have each shard of PG processing with to assign them their own ports. What happened to that?
You mean let the client to connect to a certain port and shard the PG by port.
Exactly. Client should to make client aware that
change is not backward compatible, but as long as we are able to develop two clients.
Yes, but we can. Well, we could have some slow fallback for clients that are not aware about this sharding. However, the main path, I guess, could be much faster going that way.
Yes, I think it's a way to go. And
okay, sounds good.
On the server side, the worst thing is nothing but some cross-call communication, because some client does not send the right request from the right port, but we always aware of it because the request has the PG number embedded in it, so it's not the end of the world, and we always can correct it by forward the request to the right core.
So it doesn't mean that we start sharding by PG, start from the ports, right?
Yep. Right.
Yeah, but that is a huge change, right? they will be not compatible to
Yes,
existing OSDs.
you would need to change also operators or something low level thing at client side. However,
But I think it's
for
backward compatible.
yes, but I guess we don't need to have the backward compatibility with very good performance. Even if a old client connects to a cluster, I guess it can be handled in a bit less performant way, and it still will be fine. But clients that are aware about PG sharding and start talking using the PG dedicated ports, basically shard dedicated ports, will get much benefit of that. All we will need to handle the backward compatibility will be just some extra logic in OSD's messenger, just to send the message to appropriate messenger, to appropriate port.
Yeah.
In the behalf of a non-compatible client.
Yeah.
Okay. That also makes sense.
Sorry, I can't catch up with you. So who can repeat it?
So
The idea is that we can when we to avoid the cross-core communication just because the client is sending for example, sending a message to PG1, but send a message just because the client uh, 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 established a connection to on core 0, but it is using core 0 to dispatch the request to other cores just because it tried to use to access to other PGs which is not hosted by core 0. Are you follow me?
Yes. But
Okay.
how you want to solve it?
So the one way to solve the problem is that the client it could be we can ask the client to connect to different ports regarding for if the for example if we want to talk to PG0, it could connect to port 590, and if it want to connect to PG2, it could connect to PG the port 592 on the
So
very
you
same
mean
host.
so you mean there are multiple connections, right? For just for
Multiple
one.
ports for multiple connection for multiple core for multiple PGs.
You know, right? One client write a file or radio file is cross multiple PGs. Just one file will cross multiple PGs.
Yes. So it's a client's duty to responsibility to send
And so
a
many
different request
connections,
to
and
different
I
PG.
think so. I think there's a maximum limitation, right? Maximum limitation in the Linux kernel for the connections number.
Yes.
Do you
So
think
that
it's
we can shard the for example we can shard the maximum port number of each OSD depends on how many cores that we have. On the high end OSD, high end CPU, it can have like 88 cores on a single CPU, right? So we can open 88 port and let different OS cores accepting the connection from different OSD, different ports. And the client on the client side, it need to connect, for example, to hundreds of OSD in the worst case.
Yeah, we still need to modify the client side.
Sure. For better performance, if we can live with the if we want to be better work compatible, the client side can still talk to the server side using a single port. But on the server side, we need to dispatch the request by its PG. It is targeting to the right messenger where we listen to where we're binding by the PG number.
So,
the server is still responsible to dispatch messages according to PGs, right?
For backward compatible.
Yeah.
Validity.
So I think there are two stages there. The first is to implement the dispatching logic to support the current clients, and then we can proceed to implement the sharded port solution and modify the clients, right?
Yeah.
Yeah.
Yeah. And all the
two steps.
All the nasty thing can be hidden in the
Second step.
Yeah, and in the implementation of messenger or connection.
Yes.
But the question is how difficult it is or how complicated it is for the performance, because we can live with existing code for worse performance and leave it for future for the next step where we shard the, because it's not a pure win.
Yeah.
Complicated code a lot.
And also the client should understand how many ports and how many CPUs of the OSD, right? And after that, he can understand how to send to OSD ports, because if the client doesn't know how many CPUs of the OSD, it cannot understand how to.
The client should be aware of how the certain OSD shard its PG.
Yes.
Yes.
Yeah, but this should be a part of a handshake procedure, I guess.
Yes, and it's Messenger v3, I think.
Probably. But the Messenger v2 is still working in progress. We can ask Sage and Ricardo to take it into consideration. But I learned from Greg that the short-term goal is to have a on-wire encryption, but not the multiple entity support.
That's a priority, first priority.
Yeah. So in short term, I think what we have.
Yeah, but I guess the complexity that we would need to add the handshake procedure will be pretty small. Maybe it will be just one integer. Sent from OSD to client.
Yeah. So put in other words, there's no need to embed this kind of information in OSD map. It's pretty much backward compatible in terms of the on-wire protocol.
Yeah, maybe add a feature
for messenger.
Feature bit of messenger, right?
Yeah, that's true. But again, I'm not sure this is part of our short-term goal. But we definitely look into it when we are pursuing better performance, or we find it could be
Yep. That
undermine.
sounds like step number 2, like a task for a second phase.
Yes.
I agree. But I have another concern. Should we make dispatcher a sharded service?
I think so.
So OSD should be also a sharded service.
I think with the current design, there's only a single grand dispatcher in OSD.
Yes, that's the shared design, but shared nothing design required everything to be sharded.
Yes. The messenger is sharded. OSD is sharded.
Yes.
Because they run independently on each core.
Yes, because for example, in OSD, if a PG want to send a message to a peer OSD, it had no way but just need to always need to contact the sharded messenger for the connection. By putting it another way, always need to share the connections to its peers.
Sorry, if you mean share the connection or just send back the messenger to the connection, to the core with the connection.
Yeah, there's another way to put it. Yes. Yes, I do mean it. Because the connection is shared globally.
Is globally. Connection is sharded.
Connection reference is globally shared.
So you know which core you should send the message, right? With the connection. And that core will send out the message.
For example, a PG can hold a connection, but PG and the connection is not guaranteed to be at the same call. So PG will have like a foreign pointer of the connection, right?
So you mean the core? So you mean every core has the foreign pointer can send out the message?
Yes.
Yes. Even it's a local one, but it should be using a unified interface for sending a message to a remote OSD.
Yes.
That's what I mean by shared, because the process, it's a resource. A connection is a resource shared by the process.
Okay, I see. So every core can send the message, even though the connection is not accepted by itself. He can use the foreign pointer, get the connection, and send the message.
Yeah.
Okay, I see.
Even it is not accepted on this very core or established on this core. But I assume it's not a user case to send a message or receive a message.
So the process for one client request should be like this. The client do the connect with, for example, call 0, and the call 0 accept and connected, right? And and the client send a request to call 0. Call 0 do messenger process it and get the PG number. For example, the P number belongs to the call 1. So the call 0 send the request to call 1. Call 1 will do the PG layer logical and then send the request to the traditional thread to do the blue store or other object store operation. And then from the traditional thread return to the call 1. The call 1 will send the client reply from itself by using the connection reference, right?
I'm not following you on the last part. Well,
Yeah. The traditional thread after finish the object store processing and will return to the call 1 since the
yes.
PG shard belong to the call 1. And the call 1
Hmm.
will do the final work. So for example, such as return the reply message to the client side.
I think
Call 1 will do the return message to the call 1.
No.
Needn't return to call 0.
I think it should forward the reply to call 0 because practically it is the call 0 who accepts this connection from the client.
But user side it can use the connection reference to get the connection and use that connection send the request.
Yes, but from the implementation point of view, the client in the message, sorry, in the OSD implementation on when we accept a connection from client on shard 0, it is supposed to have some code like this to. Could you mute? Anyway, it's supposed to dispatch the request by the PG and hook a continuation which expects the return code from PG0 or PG1 where the request is handled, and then continue on with whatever is needed to do after the request is fulfilled or fails.
Oh, okay,
It's not the responsibility of the shard, whoever is responsible for process the request. It's the responsibility of the shard 0 to continue on with whatever is left on for the client. We cannot take advantage of we better not take advantage of the shared connection in the process. And it's not by any good for doing so.
Okay, I see.
So the takeaway of the discussion so far is that we can have a shard by pod or shard by core design for the next step for better performance in our messenger, but we could push it for later.
Yes.
And another takeaway is that we definitely need to redesign our messenger so it will be a sharded service, and probably we need to refine the interface to hide the fact that the connection could be living on a different core. Even the sender want to send a message to to use a connection established on different core.
Yes, I have a primary implementation, and I can improve that to the expectation.
Yes. So, and regarding to Jianpeng, I will try to reply you ASAP regarding to the problem, your question on shared OSD map or shared area RU map. Oh, sorry, shared area cache. Riddle, is there anything that's blocking you?
Yep. No blockers at the moment. Just send a work in progress. Basically, a prototype of a shortcut for reads over replicated backend. Well, it seems that the OSD map is less necessary for on read path that I thought. Basically, all I need from OSD map is just its epoch version to craft the response. So the
You don't
dependency.
You don't need even need a crash.
I don't think so.
Oh, really? But how are you supposed to dispatch a oh, I see. You don't need anymore because you are not a client side. You're already aware of
Yes,
the PG number,
of course. I've got it. I've already got it from a client.
and you don't need the support of a objector, do you?
I don't think so. I need.
Cool. Yeah.
At the moment, it's very simple. It's much below 500 lines of code.
Yeah.
Well, I've just gave it a very short run under Profiler, and it seems the shortcut changes a lot of the distribution of work inside of OSD. Using the main, that's the current IO path, well, the most dominating thread thread type is of course TP-OSD-TP. But after switching to shortcut, I can see that messenger share became much bigger. I mean profiling in the whole Ceph OSD process domain.
Wow, that's impressive. So how much the shares are taken by the OSD, sorry, the messenger in your minimal IO pass, like 40% or so?
40% around, but it's on my. It's not on Incerta, Kifu. It's on my own laptops, so it's not viable. I plan to start Incerta testing today, and also I want to start poking with extensions to the read part of the object store interface. This would allow me to grab memstore and maybe the a bit reworked messenger to have some numbers quite soon. Just to verify our concept before making the official architecture, I would say.
So what has been done is the right path, and you plan
It's
to.
read path only. At the moment, it's only read path, and it's restricted only to replicated backend. EC pools are much more complicated, much more complex in current OSD implementation. Even for reads. For writes, well, the current IO path seems to be to need much more for writes.
Right.
And that's the question.
Much simpler.
Should we that's the question about order of work. Should we go as far as possible with object store modification? I mean, testing of crime zone plus read shortcut plus memstore, or maybe before going to such testing, maybe we should prepare a shortcut for writes as well. What do you think, guys?
Could you say it again? What kind of thing we could
Well,
prepare
I wonder
for
whether
the read shortcut?
sorry.
The Seastarized, you mean the Seastarized object store? Is that what I mean?
Not sure whether I've got you. When I was talking about testing, I meant not BlueStore. I meant only a memstore.
Yes, along as we pretend that memory store has share the same interface as long as we assume that the blocking cores are still blocking using the future promise interface. I think we are fine. Continue using the memory store as a replacement because to ready the blue store we need to set up the mini VM for blue store.
Yep.
And the memory store had much less dependency on. Assumedly, memory store has a much less dependency than that of blue store.
I'm pretty sure about that.
You're not sure?
Well, I am. Memstore it's far by order of magnitude simpler than BlueStar.
Yeah.
And I guess if you want to take all the store the same method.
Sorry, could you repeat, please?
Yeah. We want to take all the store, object store, memory store, blue store, or other store as the same method. So we don't.
I'm not sure. But we are supposed to use the interface exposed by object store.
Exactly.
Yes,
and
the same.
So we don't need to check all of them, right?
The question is whether each single object store implementation we have at the moment needs to implement our Seastar-driven extensions to object store. I mean something like read method of object store returning a future.
Oh, that remind me the question you posed on. You should do Sage. Mean if we want to support K store, right? You asked the question if we want to support K store in future.
Yep.
Actually, I don't really think we need to support all of the backend in Crimson.
I believe the top priority for now is just memstore. Then maybe BlueStar.
Yes.
Okay.
And if we have extra bandwidth, we can support more backend. But what merit we can get by supporting more backend?
Yeah.
I doubt it.
the, mhm. Another topic is the write path. I guess it will be very useful to have also a shortcut for it, because currently the current IO path treats all operations equally, basically. Very infrequent operation. We are well very frequently used operations like pure reads, pure writes are paying huge tax only for the sake of supporting much less frequented operations like like snapshot listing or something like that. I would also, I guess we also need to dissect, prepare a shortcut for writes. But it will, I guess it will be more complicated than the one we are working for reads.
But the question is, what's the next step
Yes,
if
right
we have the shortcut of write path? How will it help us to shape the Seastar port? I think the idea of having shortcut in existing OSD code is to help us to understand which part we need to port or which how we
exactly,
can
exactly.
build the
From the read
implementation.
shortcut, it seems the real necessary step, the most complicated step there is finding object context and going to object store just for doing read. I mean,
So
read
yeah.
path is pretty straightforward, and maybe we won't need to even dissect it to some kind of stage execution unit. It's
But
just very simple.
if by porting the read path to Seastar, we can ready all the dependency and have better understanding
Yes,
of what the
of course.
Crimson OSD would look like. We probably can dispense with the work to port the shortcut of write path to
Yep, and
to come up with the shortcut of write path.
And porting shorter, simpler code is just much easier.
Sorry, for the right path, right? Is that what I mean?
I mean, at the moment,
replica.
I'm talking about the read shortcut. I mean, it's
Okay.
much shorter than the main path, so likely it's much easier to port.
Yeah, but your question was, shall we come up with a shortcut IO path for the write operation?
Yes.
Right.
Should we focus now on on dissecting, on analyzing the right path, or maybe go with just with read path at the moment in Seastar?
I think it depends. If you feel that the right path, by implementing the right path in Crimson, could impact the model, how we shape the read path and the right path also. If it changes, if we have, let's put it this way, if it changed a lot how we shape Crimson OSD by
Got it.
looking at the right path shortcuts, we definitely need to do so ASAP, but it does not hurt, or it does not change how we shape the Crimson OSD, or it just has a minor impact on the high-level design of Crimson OSD. We can push it for later after we port the read path to Crimson. What do you feel? I think you need to use some wise judgment in this area to understand how will impact our general direction.
At the moment, I am a bit afraid about the logic for postponing some operations in main path. I mean something like doing writes on objects that we need to wait for because of recovery or something like that. That's the thing. I'm not 100% sure at the moment.
Yes, my concern is that once we, assuming that we completed porting the read path to the minimal read path to Seastar, and we end up finding that most of the code need to be refactored or rewrite to adapt to the what we learned from the right path. That would be a misery.
Yep. Well, looks we need to just take more insight on the right side of main path.
But is there something you think we can port, or we can at least starting looking at in the read path, the minimal building blocks that we can reduce in the final version of Crimson OSD. For example, we can start looking at some data structures. So you can point us to.
Well, from the current experience doing shortcut for read path, I can say that the pretty important building block is the shared LRU. It's used also by the find object context. I know two primary users of shared LRU. One is of course
shared
OSD map.
LRU, you mean? Okay.
Yep,
Okay,
exactly. Shared LRU. One is of course OSD map.
That's something we are currently working on, so I don't worry about it. And it's and the investment on shared RU will never be wasted. So it's a safe investment, I guess.
Likely. Second user is of course the object context.
Object context. Okay. I'll take a look at it. Object context. Yeah. That's something we need to have.
I mean, it's find object context is using shared LRU to retrieve object context.
Okay, so shared RU is also a dependency of object context.
It's used to store it, to manage it.
Okay, it's okay.
Because
I see.
Because it's a template. However, shared LRU is pretty interesting because it's not just LRU. It looks like a thing that combines a global registry with LRU. It's not pure LRU, definitely.
Okay. Anyway, I see we don't need to prioritize our current tasks. That's the takeaway, right? That's the point.
Yep.
Okay. Mm. Anyway, I think we need to wrap up the discussion. It's a past due for 60 minutes or for 26 minutes.
Okay.
So
Yep.
I will try to catch up with you guys ASAP after the conference and try to understand uh the uh, easy read pass and easy read pass, and we'll try to reply Jianpeng's query regarding to uh, shared cache. But I don't really think we need to worry about it because it's a single thread thing. And regarding to Redux, he will be working on. He will continue looking at the right path to see how it will impact our short-term direction. And Yinxin will try to make a messenger a shared service and to hide the underneath on in for example the lookup connection, right? And how about you?
Yes.
How about you, Chenmei? Do you have any concrete short-term goal?
Oh, I'm going to implement the memory store in the traditional thread and implement the interface.
I don't really think you need to implement memory store using traditional thread because it's already set, right?
Oh, I need to write some test, right? You test code to do the to test to implement the interface, right?
Or to adapt, what do you mean to adapt the um, memory store to Seastar interface?
Yes, currently the Seastar running in the Seastar world. We need to
Okay,
start up
sure.
the traditional thread and run the start the memory store in the
Oh,
traditional thread, and the Seastar
oh,
uh, has the interface to talk with this memory store.
I got what you mean. Yes, we
Yeah.
definitely need to
Yeah.
do so. Yes, true. And I think that's all. Jianpeng, I did you have any problem regarding to the Seastar programming? Put the question in the shared ARU aside, aside from the ARU problem. Jimo,
Hi, can you repeat your question? Sorry.
I just want to understand if you are good with Seastar programming and nothing is blocking you. Because
Uh,
regarding to your question on the shared cache, I don't really think we need to worry about the condition variable or mutex. But
yeah,
I will
yeah.
try to answer your query ASAP before the end of this week.
Yeah, last week I removed the lock and the condition.
Okay, but I think it's already removed, right? By using the stub defined in zip mutex, because if with Seastar is not defined, all the mutex is replaced with a dummy one.
Okay, I see. I will review the code.
Yes. Probably what we can do in next step is to guard the condition variable with Seastar. So it might look like if uh, if with Seastar is not defined, we can just ignore the we can just comment the condition variable out if Seastar is not defined, because it's pretty much a single threaded uh, um, cache, so we don't need to worry about the racing. Okay, I think we are all set. So, Chumi, have a good night, and have a good day, guys. Let's
Have a good
talk.
day.
Good night,
Thank
Kazu.
you.
Good night.
Bye.
See you. Bye.
Yeah.
See you.
Hello.